Okay, so in the previous video, we got our data set together, right, in which that's representing some sleep in rodents. So see that video if you didn't see that. And so now we want to model sleep, okay? And the first approach that we're going to take is just using Bayesian splines. And so if you're not familiar with this, you should check out my statistical rethinking playlist, in which I go through the questions of the very excellent book by Richard McClareth called Statistical Rethinking. And there is a section in there and some questions addressing splines, and specifically splines in a Bayesian context. Okay. Anyway, I'm going to assume that you have seen that or are familiar with splines. I'm not going to explain splines here. But anyway, so we need to build our splines. And so I'm doing that here. So I'm going to put knots of my splines at 360, 720, and 1080 minutes across the x-axis here. And my spline is going to be, my splines are going to be of degree 3. Okay. Let's just see what these splines look like. So I've built my splines, and now I'm plotting them, and I'm color coding them here. Okay, so this is what I get as a result. And the reason that I'm color coding it here is because when I go to the regression, I'm not going to use all of these splines. Okay, I'm just going to use a few of them, the ones that well, that seem appropriate. And you can play with that if you get this code. Okay. All right, so now I've taken my splines and I've identified spline 1, spline 2, all the way to spline 7. Okay, so B1 is just this column. Okay, I've just pulled it out of B, and the reason I need to do that is to enter it into the model, and I'll talk about that here. But okay, so here's our first spline model. Again, if you go back to the statistical rethinking package, or I'm sorry, the statistical rethinking playlist, and you look at how we built those splines, this formula is much longer than that other formula. In the previous splines that I used as part of the statistical rethinking package, I used, in order to do all of, well, basically from here to here, I used a shortened notation that would have looked something like this. Okay, but we can't do that here, and the reason that we can't do it is because of this little guy, this bracket with treatment there. Okay, so what is happening here? So what I want to do is I want to take each of these splines, the ones that I'm selecting, spline 3, 4, 5, 7, and I'm going to estimate how much I need to increase or decrease the size of the curve represented up here in the figure. And I want different estimates for the baseline versus the treatment, right? So W3 is going to have an estimate for the baseline guys and the guys that were treated with the substance that is affecting their sleep or potentially affecting their sleep, okay? And so in order to get that in there, I can't use the truncated notation. I have to actually spell out each and every one of these things, okay? The other term in here is this beta time treatment times time, okay? And what this is going to do is, as we go across time, hour 1, hour 2, hour 3, etc., it's going to say, well, how much is sleep accumulating independent of all of these other rhythms that are being represented by the spline, right? So this would just be a straight line of that would have an intercept at 0 and then some slope that is dependent on the rate at which sleep was accumulating, okay? So anyway, we'll see what the output here looks like here in a second. Okay, so I've ran this, and here's my my summary of the outputs, right? So I have all of my different coefficients I'm estimating, one for W3, for W4, and I have a bracket W3 bracket 2, where the ones are the W3 estimate for the control group, and the 2 is the bracket, or bracket 2 is the W3 estimate for the treatment guys. Okay, so you see that with each one of these coefficients. All right, that doesn't help us very much. So what we need to do is we need to extract now some samples from our posterior. So this is summarizing our posterior distribution. So I'm sampling from my posterior distribution here, and this is what I get, and I've called this object post. Okay, so I have samples for sigma for W3, W4, W5, W7, etc. Okay. And I'm going to add some things. So so the first thing that I need to add is for beta time. This is dependent. So beta time is one value. It's just the coefficient here, right? But at each hour, or you know, at each different time, this entire term differs, and so I need to build that out. Okay, and so the way that I'm going to do that is well, with this code here. So at each time unit, I am just simply taking I'm multiplying the beta time estimate times multiplied by the time. Okay, and so that's going to give me an average or an expected value for each moment in time. Okay, and then yeah, so with all of that, okay, I'm going to display some things here. Okay, first I'm going to display my splines that I've used, and then I'm going to see what those splines look like after each one of the splines gets multiplied by its respective W value for the two groups, and then I'm going to show you what sleep looks like altogether. Okay, so let's play this. Okay, I have some error. Let me fix this error. Okay, I'm back. I don't know what I did, but somehow I fixed it. So anyway, so I've ran this. So let's scroll down here. Okay, so this first one are the basis splines that we were using, right, as inputs to our model, right? This was B3, B4, B5, B7. Okay. And now after then we put that into the model. The model estimated the weights that we needed to multiply each of these by. And so this is those splines multiplied by their respective weights for the two groups. Okay. And then when so now I'm going to, for any moment in time, I'm going to add everything that I encounter. Right? I'm going to add the blue line to the green line at that value, as well as the intercept, as well as the average, which I have created here, right, which is the function of time. This is the beta time multiplied by time. Okay. And so now when I do that, this is what I get. The red represents the treated group, and the blue represents the placebo group. And the dots are the actual the average values of the data, and then the lines represent our spline output, right? What our model is predicting. And you can see that it gets some things right. Okay, so it definitely seems in the data that, well, in fact, we know it's the case because we built the data, that the treatment group is sleeping more, is accumulating more non-REMs than the control group. But these are very linear lines. Like, they are not grabbing, or they're not capturing kind of the contours of the sleep. Okay, and so this suggests that we need to maybe try something different, and that's what we will do in the next video.